Okay, so now in this video, we're going to discuss the last idea in this section of energy, which is power. And power have to do with how fast you can use energy. So the definition of power is the change in energy divided by the change in time. That's your definition of power. Remember, the change in energy comes from the work that you do, the energy that you transfer into the system. So that energy divided by the change in time, that gives you the power. What are the units of power? The units of power are watts, and they are, if you use 1 joule in 1 second, that is 1 watt. So another equation for power comes from rewriting the work as force times displacement. Remember, that is our equation for work. So if you take force times displacement and divide that by delta t, right? So that is your power. So now delta x over delta t, that is the velocity. So you end up with this equation here that says that power is equal to force times velocity. So let's look at an example to try to understand power. So we have 4 students here. So A is going 10 meters up. B is also going 10 meters up. C is going 10 meters up. And D is going 20 meters up. Now A is going 10 meters up in 10 seconds. B in 8 seconds. C in 8 seconds, and D in 25 seconds, right? Now, C is a little lighter than the other 3, so the question is which one has the largest power output? Well, let's calculate the power outputs, right? So for A, it would be mgh, which is 80 kilograms times 9.8 times h, which is 10 meters, and then that divided by 10, which is 10 seconds, right? And I'm not putting the units just to save space. So this is equal to 784 watts. So by doing this every second, he's using 784 joules of energy. How about B? Well, B would be using, we do the same, 80 times 9.8 times 10, which is the height, but now we divide by 8 seconds. That is the time that it took for him to go up, and then that gives me 980. So his power output is greater than 8, right? So, and that's the difference. He's using the same energy, but he's using that energy quickly in 8 seconds as opposed to 10. So let's look at C, right? So C is going in 8 seconds, same as this, right? But C is lighter. So let's do that. 64 kg times 9.8 times 10 meters up divided by 8. That gives me 784. So these two have the same power output because even though C is going faster, C is lighter, so it needs less energy to go up the stairs, so right? And now let's look at D, right? So D has 80 kgs times 9.8 times 20, and all that divided by 25 seconds. That gives me 627 watts. So D is the one with the lowest power output. So this is the main idea of power, and so it's just energy used per unit of time.